Will AI replace software engineers? That is the single biggest question in tech. But forget the hype and opinions. Let's look at the actual data for 2026. The answer isn't a simple yes or no. The reality is far more interesting. In the next few minutes, you will learn the three critical shifts happening right now that are redefining what a software engineer even is. We'll break down which jobs are quietly vanishing, which new hybrid roles are exploding in demand, and the one skill that now separates the engineers who will be replaced from those who are building our future. Let's start with the most urgent data point. Gartner's analysis is clear. The impact of AI isn't about elimination, it's about transformation. They predict a major reduction in entry level roles because AI allows senior staff to automate the exact tasks they once assigned to juniors. This isn't a future prediction, it's happening now. The job market is already seeing a significant drop in entry level developer positions. If your primary skill is just writing routine code, you are on the wrong side of this divide. So, how does this play out? The first major shift is the death of the code monkey. For years, the entry level software job was simple. Take a well defined task and just write the code. Fix a simple bug. Create a basic component. That entire category of work is being automated. AI tools like GitHub Copilot X are now incredibly good at writing that routine, boilerplate code. Think of a senior architect who no longer needs an apprentice to carry bricks. They have a machine that does it instantly. This means the bar for entry level talent is getting much higher, much faster. The second shift is the rise of the AI-Augmented Engineer. This is not just about using an AI assistant to write code faster, it's a fundamental change in the job itself. The most valuable engineers are no longer just writers of code. They are becoming editors and architects of AI-generated systems. Their core task is shifting from line-by-line implementation to high-level design, strategic prompting, and rigorous validation of what the AI produces. Your value is no longer in how fast you can type, but in how well you can think and direct the machine. This leads to the third and most important shift, the emergence of entirely new hybrid roles. While low-level coding tasks are disappearing, the demand for engineers who can bridge the gap between software and AI is exploding. We're seeing a huge spike in roles like AI systems engineer, MLOps specialist, and AI product engineer. These are not just rebranded software jobs. They require a new blend of skills, part software architecture, part data science, and part business strategy. They focus on integrating complex AI models like those from OpenAI or Google's Gemini 3 Pro into actual working products. These three shifts, the automation of junior tasks, the new AI-augmented workflow, and the creation of hybrid roles, are not separate trends. They are all part of one massive reshuffling of the tech industry, and they all point to one critical conclusion. The core skill that determines an engineer's value is no longer the ability to write code. It's something else entirely. Understanding this one distinction is the key to not just surviving, but thriving in the age of AI. So, what is that skill? Let's break it down. The single most valuable skill in the age of AI is not a programming language. It is not a framework. It is not even prompt engineering. The one skill that now separates the highest paid, most resilient engineers from everyone else is AI native systems thinking. I know that sounds like a buzzword, but let me show you what it actually means in practice. Imagine you're building a house. For the last 20 years, a software engineer's job was to be an expert craftsman, a master carpenter, a skilled electrician. You were given a blueprint and told to build a perfect wall or wire a perfect circuit. Your value was in the quality of your craft, your code. AI native systems. Thinking is a completely different job. You are no longer the carpenter, you are the architect and the general contractor combined. You don't just build one part of the house. You design the entire system and you decide where to use a master craftsman and where to use a team of powerful but simple-minded robots. The AI models, like GPT-4o or Claude 4.5, are your robot workers. They are incredibly fast and efficient at specific tasks, like cutting wood or laying bricks. But they cannot design the blueprint. They do not understand the homeowner's needs. They do not know how the plumbing, electrical, and foundation all need to connect. That is your job. So what does this look like in the real world? Let's walk through a case study. Imagine a mid-sized e-commerce company that wants to fix its customer support. The old way would be to hire a team of software engineers to build a new ticketing system from scratch. This would take 6 months and cost $500,000. The new way, the AI native systems thinking approach, is different. An engineer with this skill doesn't start by asking, "What code should I write?" They start by asking, "How can an AI system solve this business problem?" First, they decompose the problem. Customer support is too broad. They break it down: order tracking, refund requests, product questions, and technical issues. Now, here is what most tutorials get wrong. They jump straight to building a single chatbot. But the systems thinker knows that a single chatbot is a blunt instrument. They see the problem as an assembly line that needs different tools for different stages. For order tracking, they realize you do not need a complex AI. A simple database lookup, automated through a basic script, can handle 90% of these queries instantly. This is a job for a simple robot, not a genius one. For refund requests, it is more complex. Here, they integrate a large language model, but they do not just connect it to the chat window. They design a system. They use an AI model to first categorize the refund request. Is it a damaged item, a late delivery, a wrong size? Based on the category, the system automatically pulls the customer's order history. It then provides the AI with a strict set of rules and information, a pre-written brain for handling refunds. The AI, perhaps Gemini 3 Pro, then drafts a response. Something like, "It looks like your package was delayed. We've automatically issued a refund of $47.99 to your original payment method." This entire process happens in seconds with zero human interaction. But what about truly complex product questions? The AI might not know the answer. The systems thinker builds a fallback. The system is designed to recognize when the AI is uncertain. When its confidence score drops below, say 85%, it does not guess. It automatically escalates the chat along with the entire conversation history and the customer's order data to a human support agent. The human does not start from scratch. They have all the context they need to solve the problem in 2 minutes instead of 20. This is AI native systems thinking. It is not about writing one piece of code. It is about orchestrating a multi-part system where AI models, databases, business logic, and humans all work together. The engineer's value was not in writing Python code. It was in designing the workflow, selecting the right AI tool for each step, and building the connections and guardrails between them. The result? The company did not spend 6 months building a new platform. This system was prototyped in 3 weeks. It handled 68% of all incoming support queries automatically. This did not lead to firing the support team. It freed them up from repetitive tasks to focus on the high-value customer interactions that actually build loyalty. The project saved the company an estimated $430,000 in the first year alone, not from cutting salaries, but from increased efficiency and reduced customer churn. If you're starting to see how powerful this shift in thinking is, make sure you're subscribed because we're about to break down exactly how you can build this skill for yourself. And here is the uncomfortable truth. Your ability to write perfect clean code is becoming less of a differentiator. The AI can write clean code. GitHub Copilot can refactor your functions and suggest elegant solutions. What it cannot do is what I just described. It cannot look at a business problem, decompose it, and design a complex multi-agent system to solve it. That is the new defensible skill for a software engineer. So how do you develop this? It comes down to 3 core pillars. The first pillar is problem framing. Before you write a single line of code, you must define the problem in a way that an AI can solve. This means moving beyond technical specs and thinking like a business strategist. Instead of asking, "How do I build an API for user data?" you ask, "What is the most efficient way to give our customers the information they need at the exact moment they need it?" Notice the shift. One is a technical task, the other is a system-level goal. The best engineers spend most of their time here, at the whiteboard, designing the flowcharts and diagrams of the system before any code gets written. The second pillar is tool selection and integration. The modern software engineer is no longer just a coder. They are a high-tech integrator. Your toolbox is not just programming languages anymore. It includes a vast array of foundation models, vector databases, and specialized APIs. Your job is to know when to use OpenAI's GPT-4o for its creative reasoning, when to use Google's Gemini 3 Pro for its multimodal capabilities, and when to use an open-source model for cost and privacy. You then need the architectural skills to glue these components together into a reliable, scalable product. This is where traditional software engineering skills remain critical. but they are in service of a larger system, not just a standalone application. You might be thinking, this sounds like a product manager's or an architect's job. You are partially right, but here is the key difference that makes an engineer with these skills worth over $300,000 a year. You can actually build it. A product manager can design the what. An AI native systems thinker can design the what and then build the how. They have the technical depth to not just imagine the system, but to bring it to life. This combination of strategic thinking and technical execution is incredibly rare and therefore incredibly valuable. The third and final pillar is validation and guardrails. AI models are powerful, but they are not perfect. They can make mistakes, they can be biased, and they can fail in unpredictable ways. The most critical part of an AI engineer's job is to build a safety net around the AI. This means creating automated systems to test the AI's output. It means implementing guardrails that prevent the AI from giving harmful or incorrect answers. It means designing monitoring systems that can tell you in real time how the AI is performing and when a human needs to intervene. An engineer who just connects to an OpenAI API is a liability. An engineer who wraps that API in a robust system of checks and balances is an invaluable asset. This is the difference between building a tech demo and building a production-ready, enterprise-grade AI solution. These three pillars, problem framing, tool selection, and validation, are the foundation of AI native systems thinking. This is the skill that separates the engineers who will be replaced by AI from the engineers who will build the future with it. It is a shift from being a craftsman of code to becoming an architect of intelligent systems. Now, knowing the three pillars is one thing, but putting them into practice is where 90% of engineers get stuck. They fall into two critical traps that completely sabotage their efforts. Avoiding these is the difference between a six-figure AI project that succeeds and one that quietly gets shut down after 6 months. The first mistake is what I call tool-first thinking. An engineer hears about Gemini 3 Pro's new capabilities, and their first instinct is to ask, what cool thing can I build with this? This is completely backwards. It is like a carpenter buying a new laser saw and then running around looking for things to cut. The AI native systems thinker never starts with the tool. They start with the business pain. The tool is always the last decision, not the first. The second, and more costly mistake, is trying to build one giant monolithic AI brain to do everything. This is the most common failure pattern I see. A mid-sized tech company learned this the hard way. They spent 8 months and over $200,000 trying to build a single all-knowing AI assistant to handle all of their internal HR questions. They tried fine-tuning a massive model on every single company document. The result was a complete disaster. It was slow, expensive, and confidently gave incorrect answers about payroll and benefits. Why did it fail? Because they asked one AI to be a master of everything. Now contrast that with a team that used AI native systems thinking. Their architecture diagram was not one big box, it was a flowchart. For simple questions like, how many vacation days do I have left? They used a simple, fast API call to their HR software. No AI needed. For more complex policy questions, they used a system called Retrieval Augmented Generation, where a model like Claude 4.5 was given the exact 3 paragraphs from the employee handbook it needed to answer the question and nothing else. And for sensitive, personal questions, the system was designed to immediately escalate to a human HR representative. The proof is in the results. The monolithic project was shut down. The systems thinking project was rolled out in 6 weeks. Its dashboard showed that 70% of HR queries were being resolved instantly, and employee satisfaction with the system was at 92%. The head of HR said it freed up her team to focus on culture instead of paperwork. We go deep into practical AI engineering like this every single week. If that's your goal, hit the subscribe button so you don't miss the next video where we will actually build a portfolio project using this exact method. So how do you scale this approach? The pro tip is simple: decompose and orchestrate. Do not try to boil the ocean. Find one tiny, repetitive task in a workflow and automate just that piece. Then find the next one. Your job is not to build a genius robot. It is to build an assembly line of simple, efficient robots that together create a genius-level outcome. This is the scalable, defensible skill that separates the new generation of AI engineers from everyone else. So, to answer the question we started with, Will AI replace software engineers? The answer is no, but it is already replacing the engineers who think like craftsmen instead of architects. Your value is no longer just in writing code, it is in designing the intelligent systems that use it. Your one action for this week is this: find one repetitive, manual process at your job. Do not think about code. Just get a whiteboard and draw the flowchart of how an intelligent system could automate it. Identify the decision points, the data needed, and where a human should intervene. This is the first step to building that systems thinking muscle. This shift is the single biggest career opportunity in tech right now. The engineers who start thinking this way today are the ones who will lead the next decade of innovation. If this video helped you see the path forward, subscribe for more content on building a future proof career in tech. In the next video, we will break down how to build your first AI native systems project for your portfolio.